Hi students, how's everyone doing? I hope you guys are doing okay. I'm doing fine. Um, so what I want to start with is with closed space. And I'm going straight from the book, page 74. So closed space is the concept of every frame line or every image has the frame line around it, right? And certain images emphasize that frame line. And or I should say all images emphasize that frame line. And so he gives us even vertical lines and horizontal lines will emphasize the frame line. He gives us a couple examples of that. And then he reduces it to a high contrast shot. And you can actually see the frame lines and how the vertical lines contribute to it. Okay? That's considered closed space. So the opposite of that would be open space. And open space is hard to hold, hard to create. And it doesn't have to do with the desert or the sky or anything like that. It has to do with that boundary line around the screen. And certain images, certain shots appear to push beyond that boundary line. It's very difficult to hold. Open space is a unique type of space that can exist outside the frame lines of the screen. It's difficult to create, but when it does occur, it pushes past the closed frame lines and the surrounding pictures and gives the audience a sense of space outside of the frame. So it gives you this sense of a space that exists outside of the frame. And now he talks about a couple things that we need for open space. Number one being a large screen. The TV screens or a TV screen isn't going to do it because he claims that it's not big enough. But also, we are impeded by lines in the living room. We need a large screen, like one that we see in a theater, or think IMAX. The bigger, the better. We need strong. Oh, it's easier. It's easy to produce open space on a large screen. The bigger the screen, the easier it gets. Giant IMAX screens can easily generate open space, but large conventional movies and screens in theaters can work almost as well. As the screen size increases, the lines move to the edges of our peripheral vision. So the larger the screen size, right, the more the edges of the screen, they move out to our peripheral vision. They keep going further and further out. So movement is one of the components that is needed for open space, and you can have a certain different kind of movements. One is like a random movement in all direction, right? And that's like, and he gives an example here, like an overhead shot where everybody's moving in different directions. A random multidirectional movement that fills the frame may have enough visual intensity or dynamic to push open the frame lines and create open space beyond the actual frame. As the audience watches the screen, the movement will visually overwhelm the frame lines and the audience will sense the visual space outside of the frame. Movement in or out of the frame can also create open space. The movement must be large in relation to the frame, slow enough to be seen by the audience, yet fast enough to generate visual intensity to overpower the frame lines. An example of this would be the opening shot of Star Wars, where that big spaceship comes flying overhead. It rumbles off into the distance. That gives us a sense of something existing and pushing the boundaries of the frame line. Open space is also created when spaceships in Star Wars travel to light speed. Think of like when you have those jump to light speeds and you see the streaks, all the sudden streaks of light like my sound effects, the sudden streaks of light, that creates open space as well, because it overwhelms the boundary of the, or gives you the feeling that it overwhelms the boundary lines of the frame. The next camera movement is random camera movement on the axis. So every camera has an axis that it turns left and right and up and down. So camera movement can also be used to create open space, although the movement won't be multi-directional. Like multiple objects in the frame, random camera movement, including rotations on the axis of the lens, can help create open the visual space. So they're talking about on the axis of the lens. Like if I'm shooting, let's say this is a camera, right, and the lens is shooting this way, right, or shooting at you, it can move like this, but not like this. That's not the axis of the lens. The axis of the lens would be like this, left and right, left and right. If the movement is random and of sufficient speed and agitation, everything in the frame will move in opposition to the stationary frame lines. This increases the visual dynamic created by camera movement and may be enough to overpower the frame lines and create open space. So remember, it's all about everything that's going to overpower that frame lines. Also, to create open space, we have to eliminate stationary lines. In creating open space, any line that emphasizes the frame line must be removed. Open space is so delicate that closed space components like stationary lines will easily overwhelm the open space and keep the frame closed. He gives us some examples. So we have to eliminate all these horizontal and vertical lines that emphasize the frame. Okay. So I've mentioned this before, this idea, or I keep mentioning it, this idea of contrast and affinity. Contrast means different, affinity means same. And how we can contrast or use a contrast or an affinity of any of the subcomponents. But also now we're going to talk about contrast and affinity of these components at a deeper level. For example, the first one is contrast and affinity within one shot. So we can take one shot and I can say in that shot I'm going to have an affinity of space, meaning I'm going to show nothing but flat space, right? So that means everything in that shot will be flat. Now if I want a contrast within that shot, I would have portions of it that are flat and deep, okay? Like this. There's an example. This is an example of contrast within the shot. One side of the shot is deep space, and the other side of the shot right here is flat. So that's contrast within one shot using space. This is an affinity within the shot using flat space. You have flat space on the left and flat space on the right. So that's an affinity within the shot. Remember, affinity is same. And when things are the same, the visual intensity is less. It is decreased. When things are different, when there's a contrast, the visual intensity is increased. Okay? Always remember that. Always remember that. Okay? So, not only can we contrast not only can we have a contrast or an affinity within a single shot, we can have two shots, and between those two shots having an affinity or a contrast. For example, I can for an affinity, I can have two shots that are flat space, like this. Flat is one shot, and then my second shot is flat as well. So there's an affinity of space between shots, flat. So the impact of those two flat shots would be less visually intense than, let's say, the impact of two shots where they are in contrast. For example, here we have one shot that's flat, right? And then here we have a next shot that's deep space. So if we put those two together, going from this shot to this shot, there's a contrast. So these two together will be more visually intense or visually interesting than these two together. Now, when I say visually interesting or visually intense, don't think in terms of right and wrong, or this is a proper way to shoot something or the wrong way to shoot something. It's just a value of the shot, a quality of the shot. And you're free to use them in any way, just as long as you experiment, right? So, principle of contrast and affinity can also occur from a sequence of shots. So I can have a series of, let's say, 6 shots, and then compare that between another series of 6 shots. I can have a contrast within the shots or an affinity within the shots. So we have contrast and affinity in a single shot, contrast and affinity between 2 shots, and contrast and affinity within a sequence. Hopefully that makes sense. If not, drop a question in the discussion board and I will elaborate on it as best I can. The principle of contrast and affinity can also be used for ambiguous space. You can use that principle, contrast and affinity, for pretty much everything. Everything that we look at goes through that lens of contrast and affinity, pretty much, right? You can use it for ambiguous space, recognizable space, open and closed space, and surface division. There isn't a right or wrong in this. Like, you can't say, or it would be incorrect to say deep space is right and flat space is wrong. Again, they're just qualities of space that you're looking at, different characters that we're different characteristics of the space that we're observing and putting a name to, so that we can understand them and talk about them. I'm just looking down at my notes here. Okay, moving on to chapter 4, page 87 in the book. And so this part of the book, this is the part where we go into the subcomponents even deeper in each individual one, starting with line. All right, so line. Line differs with the other visual components because line appears only due to tonal or color contrast. Depending on the contrast, a line can be revealed or obscured. So line only appears due to tonal or color contrast, right? Like, say if I have a ball this color, or a shape this color, and put it right here, it won't have any shape or any line because it's the same color. these cards have a line or form a line because there's a contrast between the colors of this green or this foam ocean color, whatever it is, and the white. So there appears to be a line there, but it's really the contrasting colors. Okay, so let's talk about lines for a bit. The apparent line around the borders of any two-dimensional object is called the edge. And then he gives us a drawing of a piece of paper. Right there, that little square. That's a drawing of a piece of paper. And obviously, a piece of paper is not truly two-dimensional, but it can be considered two-dimensional for our purposes. When you look at the drawings of 4 lines, you imagine a piece of paper. Examine a real piece of paper like this book. All right? We accept the 4 drawings. We accept this drawing of 4 lines as a representation of the edges of the page, but actually a piece of paper is, or any two-dimensional object, has no lines. Why? So why do we accept that as lines? Okay? Because lines only appear in real life if there's tonal or color contrast, right? Because there's this contrast between the colors. There's a contrast between the white of this paper and the black on my shirt. And where those two meet, there appears to be a line. Okay? That's one notion of line. The next notion would be the contour of something. And man, I wish I had my grandbaby comes and plays in this room sometimes, and sometimes he'll leave a ball in here, so I don't have a ball or anything to show you the contour. The apparent line around the border of any three-dimensional object is called contour. Most objects in the real world are three-dimensional, having height, width, and depth. We perceive a line around these objects. A basketball is a three-dimensional object. We accept the curved line around the ball as the border of the ball itself, but a real ball doesn't have a line around it. Our perceptions create the line. So these are perceptual facts. Okay, here's a photo. Here we have a photo of a ball right here. And we perceive the line around it, the contouring around the ball, as the line. Okay? Is there a line? This is a book with flat pages. You're watching this on a TV screen that's also flat. It's two-dimensional. It's impossible for there to be a third dimension here, or even on your screen, all right? Because it's flat. So the mind, when the mind sees the contouring of shapes, three-dimensional shapes, it forms a line. It perceives a line around that shape, that object. The next type of line is kind of trickier, and it's called closure. Okay? And we have these things called primary points of interest, and those are our eyes and our face. These are primary points of interest. What does that mean, primary points of interest? Well, it means that whenever a face or their eyes on the screen, your eyes, the audience's eyes, are drawn there, and they're going to draw a dot or a point there. So let's say if there were 2 people side by side, right, it's going to draw your mind, not a real line, your mind draws a line between my eyes and the person's eyes next to me. Does that make sense? That's called closure. Now, if you add third line, the third person, like this, boom, 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 now we start to create shapes with that closure. And this one, the shape we're creating is a triangle. The line represents a triangle. Here's one where it's a single line between the points of interest. Okay? So that has to do with our eyes, closure, points of interest. Okay? Our mind we are drawn to our eyes. And when we see the eyes or more sets of eyes, that points of interest, we draw a line from one point of interest to the next one, to the next one, to the next one. And we create, in our mind, we perceive shapes. We don't see the shapes on the screen, right? They aren't real, tangible shapes and lines. They are perceptual lines, perceptual facts. The next type of line I want to talk about is intersection of planes. And this one is really simple. When two planes meet or intersect, they appear to create a line. Here we go right here. We have one plane going this way, and another one coming that way. And where they intersect, there appears to be a line. And that could be like the edge of a wall, or two walls coming together. There appears to be a line there. Every corner of every room can create a line if there is tonal contrast between the two planes. So for this requires tonal contrast or color contrast, one of the two. And this is what he means by that. Here's an example. Oops. And now he can add more contrast to the lines, more tone, or less tone here. I'm sorry. This is more affinity. But then look what happens when we emphasize those shapes. And it creates lines. And all he's doing is emphasizing the corners where the walls or edges meet. All right. So where we have planes that intersect each other, we see a line there. The next one is imitation through distance. Imitation through distance occurs when an object appears to reduce itself to a line or lines because it's so far away. And here we have an example. Power lines. They are so far away that they just reduce themselves to a line. And that's imitation through distance. The next one is axis. Excuse me for 1 second. With all the smoke and fires going on, yeah. Anyway. Many objects have an invisible axis that runs through them, and this is perceived as a line. People, animals, and trees are examples of objects that have an axis. A person standing has a vertical axis. A reclined person has a horizontal axis. So this person has a vertical axis as he's standing up, right? There's an imaginary line that runs through him. And this guy laying down has an imaginary axis that runs through him. All right? His is horizontal. His is vertical. So all objects have an axis, except for round objects. Actually, a round object does have an axis, depending on the direction it's moving. An axis, like most types of lines, need contrast to be seen. The axis becomes difficult to define when tonal contrast between the objects and the background is reduced. So, if your object can't be distinguished from the background, it's going to be harder to tell the orientation of the object, if it's going vertical or horizontal. So the object must have contrast to its background in order to stand out. Once it stands out, we can see the axis. That's what he's saying there. The next one, not all objects have an axis. A square has no definite single axis, but a rectangle does. There we go. track. The next one line is track. And track is simple. Track is simply the path of a moving object. As any object moves, it will leave a track or line in its path. There are two types of tracks. An actual track, like this, and that's being left by an airplane flying through the air with smoke, right? And then a virtual track, where there's no smoke coming out, but the path of the airplane itself is leaving a line or a track. So we have virtual tracks and actual tracks. Okay. So next moving on, we have this concept of this thing called a linear motif. And what is a linear motif? A linear motif is when you take an image and you reduce it to its highest contrast. Okay? And he states this: any picture can be reduced to simple lines. This is called a linear motif, simple lines. A picture's linear motif can be a combination of circular, straight, vertical, horizontal, or diagonal lines. So he gives us an example of an image, right? And then below it, this is its linear motif. It's been reduced to simple lines in black and white. And why would you, first of all, how do you do this? There's a lens that you can use that will do it. Or you can also kind of squint your eyes at objects, and it'll reduce all the detail and give you like sort of a linear motif when you squint. This helps you see, let's say you may want to set up shots, or let's say you're doing a sequence of shots, and you may want to use contrasting lines. Well, you can use linear motifs to check those lines to make sure they are actually contrasting. Okay? So, line is used, sorry, I had to gather my thoughts. Line is used to produce contrast and affinity in three ways. Okay? Orientation, direction, and quality. Orientation could be like vertical, horizontal, diagonal, right? Orientation, direction, and quality. Quality is it a curved quality, or is it a curved line, or is it a straight line? And remember, contrast and affinity still can occur within a shot, or from shot to shot, or in a sequence of shots. Okay, so under orientation, orientation is the angle of lines created by non-moving or stationary objects. Most lines created by edge, imitation through distance, and the intersection of two planes are stationary. This includes room corners, doors, windows, furniture, sidewalks, curbs, trees, buildings, etc. The three angles of line orientations are horizontal, vertical, and diagonal. Okay? A linear motif is created by the orientation of the lines. The linear motif of each picture is diagrammed in the accompanied drawing. If you can see the linear motif created by orientation, squinting at the picture to remove extraneous details that camouflage the lines. So he just gives us a couple of examples of linear motifs here. And this one's orientation is horizontal. Horizontal here, but you have a vertical line here. Okay. And he gives us another example, some more examples. All right, you can see from this shot, we get this linear motif. Sorry about the glare. It's nothing I can do about that. But you guys get these images are in your book as well. Now this is diagonal lines. And the reason why we want to know, because the orientation of the line has different visual intensities. Okay, diagonal being the most visually intense, because we don't see diagonal lines a lot. We see a lot of horizontal and vertical lines, but diagonal lines are the most visually intense. The least dynamic is the horizontal line going across like this. So you got more dynamic. You got most dynamic is the diagonal, or the most interesting. Then the least interesting would be the horizontal. Okay. Direction refers to the angle of lines or tracks created by moving objects. In the following drawings, the arrows indicate the direction of the tracks made by moving objects. And now he gives us a bunch of arrows showing us the direction of moving objects. So direction is the line made by moving objects. So, like, for example, if there were a question on our on a test that said which direction refers to what, or direction refers to the angles and tracks of what type of objects, what would the answer be? Moving objects. Okay, so different quality of lines. We have the quality of lines, we have a straight line going all the way to a curved linear line. And that's the quality of lines. And I think I'm going to stop there. I went too far. So all of this, you guys, again, coming back to the filmmaker in us all, taps in. We all have to look at this through the lens of contrast and affinity again. Contrast being most interesting, affinity being least visually interesting. Contrast and affinity, and how we're setting up this visual structure, this system, visual system to tell a story. Okay, and you take the contrast and affinity, those visually interesting ones, and you marry that to the parts of a script that are visually interesting, or I'm sorry, that are that are interesting in the script. But we'll get to that later. So enjoy the movie for the week, and put your questions in the discussion board, and I'll see you on the other side.